Question 1 tells us that the animal farm opens in 1985 and the current year is 2022, but of course you can do this with whatever the current year is that you're in watching this. So it creates this subtraction question, and I think what's key here is to include the working, not just to do the maths in your head, but to show what your thinking was. So here we can see the 2022 take away 1985, and then we can work this out, okay? Obviously, 2 take away 5 you can't do, so you need to borrow from the 2 here. Becomes a 1, that becomes 12. 12 take away 5 is 7. 1 take away 8 you can't do, so you've got to go all the way over here and borrow from the 2, becomes a 1. That becomes a 10, you've got to borrow from that, that becomes a 9. That then becomes an 11. 11 take away 8 is 3. 9 take away 9 is 0. 1 take away 1 is 0, so it becomes 37 years that the animal farm has been open. Next question asks about entry prices. So we're buying tickets for 2 adults and 2 children. What's that going to cost us? So it's going to be 2 adults. So 2 times the adult price, which is $46. And we're going to add on to that 2 times the child's price, which is $30. So 2 46s are 92, plus 2 30s are 60. So that's going to cost us $152 to get in. The next part asks us to compare that to the price of a family ticket, which is also 2 adults, 2 children, and see what cost saving would be made if we bought a family pass instead. So that'll be $152, take away $135, and that tells us that the cost price saving is going to be $17. Next question looks at the idea of feeding these pigs, and the pigs eat 4 kilos of food per day each. So if we've got 23 pigs, it's going to be 23 multiplied by the 4. So that gives us how much they're going to eat in one day. Okay, so 23 pigs will eat 4 times 4 kilos, and then we're going to multiply that by 100 to get the total that it'll be over 100 days. And then ultimately, 4 times 23 is 92, times by 100, it's going to be 9,200 kilos of food. Next question asks us to list all of the prime numbers 50 to 60. So I've listed all of the numbers 50 to 60, and just to sort of show you how we can eliminate these and just end up with the ones that are the answers. Prime numbers are numbers that have 2 factors. So anything that's an even number in this scenario is going to be excluded. So we can get rid of all of the even numbers to start with. So they're all out. That's the easiest one to get rid of. Then we want to think about our divisibility test for the number 3. So any number that if you add the digits together add up to 3, 6 or 9 is a multiple of 3. So 5 and 1 is 6, so it's a multiple of 3. 5 and 7 is 12, and 12, 1 plus 2 is 3, so that's a multiple of 3. So that's easy to eliminate. And then the last one here, you've got anything that ends in a 0 or a 5 is a multiple of 5. So we end up with just these two, 53 and 59. The 2 numbers left over, and they are the 2 prime numbers between 50 and 60. Okay, 7 plus negative 18. So a plus and a negative makes a negative. So this question is actually 7 take away 18. So it's going to be an answer that's less than 0, and 7 take away 18 is going to leave you with negative 11. Okay, negative 8 take away negative of the square root of 16. So the square root of 16 is 4. So for some of you, so square roots equals a number that multiplied by itself will give you the original number inside, as in 4 squared. So 4 is here, so it becomes negative 8. Take away creates a positive, and 4. So negative 8 plus 4 will become closer to 0, so that becomes negative 4. Three squared multiplied by 2 cubed. So 3 squared is 3 times 3, so that's 9, multiplied by 2 cubed, which is 2 times 2 times 2. So the 3 here indicates how many 2's there are here. So 2 times 2 is 4, times 2 is 8. So 9 eighths, and that's in a times table, that's nice and easy, 72. Clearly we have a Bodmus question here, and we've got to work the brackets out first. So let's just 11 take away 4 is going to leave us with 7, okay? And then we're going to have 8 divided by 2 is going to be 4, okay? And so now we can do 4 plus 7 is going to give us 11. So that's the brackets worked out. So our next line of working will be 5 multiplied by 11, and then that will give us an answer of 55. Here we have a Bodmus Fractions question, and so we need to look at this and go, which part of this question do we need to do first? We're not doing this just left to right. Bodmus forces us to do this part of it, the division part, first. So the 2/3 just sits there while we work out the rest of it. So the 2 1/3 just sits there, and we're going to add on to that. So it's 4 1/6, which we turn into an improper fraction. 4 6s are 24, plus 1 is 25 over 6. Okay, so we want to keep that, so we keep it but as an improper fraction, change and flip. Now we can do a little bit of cancelling here. We can, 2 goes into 6 3 times and 2 goes into 8 4 times. And so then that's going to equal, 4 times 25 is 100 over the top of 3 times 7, which is 21. And 2 1/3, so 2 3s are 6 and 1 is 7 over 3. So we've got 7 1/3 plus 1 over 100 over 21. So you can see here we need to find common denominators, and 3 and 21 have a relationship because 3 goes into 21. So multiply by 7 for both of those, and we're going to end up with 49 over 21 plus 100 over 21 equals 149 over 21 as our final answer there. We can turn that into a mixed number. So 21 goes in 149 7 times, and there's going to be 2 left over. 7 and 2 over 21. All right, so highest common factor of 36 and 48. So we want to list the factors of 36 and 48. So 36 and 12 and 9 and 4 and 3 and 2 and 1. I've left 1 out here, which would be 18 in there, okay? And then for 48, it's going to be 48, 24, and it's going to be 12, and I've missed 1 out there. And 16, sorry, 16, and 8, and 6, and 4, and 3, and 2, and 1. And so then it's, those two are the highest in those 2 sets of factors. Lowest common multiples, the next question for 12 and 8. So we just need to list the multiples of each of those numbers. And here 12, the multiples of 12 will be 12, 24, 36, 48, 60, etc. And for 8, 16, 24, 32, 40. And we're after the multiple that appears in both rows and is the lowest. So 24 appears in both, and it's the lowest number out of both those lists. Okay, next question asks us to put in some symbols, whether it be greater than, less than, or equals. For these sorts of questions, if you have any level of confusion with these, I would suggest that you draw yourself a number line, and then you sort of position your fingers on the number line where those numbers are to see which one is larger than the other one. So here you've got -6 compared to -5. So -6 is less than -5, so we want to put a less than sign in here. -10 is greater than -15, so we want to put a greater than sign in here. 8 take away 10 is -2, so -2 is equal to -2. And here we have 7 squared is 49, and the square root of 49 is 7, so 49 is greater than 7. This question asks us to look at the idea of temperature from a heater and how something is dropping or changing. And this question asks for the temperature change. So it starts at 35 degrees, it drops 11, and then it drops by 5 more. So how much has it dropped? It doesn't ask us what the temperature is, it asks us what it's dropped by. So it's actually just these two numbers added to each other. So it's actually dropped in total 11 plus 15. So it's actually dropped 16 degrees, how much it's changed or dropped. Now it tells us that it's going to continue to drop by 3 degrees, and we need to discover when it reaches 7 degrees. So it's going to continue dropping each hour by 3 degrees. So what we can do is we can work out at 5 degrees, it was 35 degrees, take away the 16, which we got from the previous answer. So it's currently 19 degrees. It drops a further 3 degrees. So now it's 19 take away 3. Okay, so 19 take away 3 equals 16 degrees Celsius. Then at 7 p.m. it'll be 16 take away 3. It's then at 13 degrees Celsius. 13 take away 3. At 8 p.m. it's 10 degrees Celsius. And then finally at 9 p.m. it's 10 take away 3 equals 7 degrees Celsius. And that's the trigger point where the alarm goes off. So our answer is 9 p.m. All right, now we're looking at the idea of sheep and lambs, and it tells us that there are 45 sheep in animal land, and 2/3 of the sheep have a lamb. And that's our cue in the sentence, 2/3 of. So 2/3 of is times, and the sheep. How many sheep are there? 45. So 45 over 1, okay? And we can cancel the 3 and the 45. 3 15s are 45. And so that tells us 2 times 15 is 30, so there are 30 lambs. Tells us then that Mr. Fox visits, and he is going to take 2/5 of the lamb. So just like the previous question where we had 2/3 of the sheep, now we have 2/5 of the lamb. So it's the same process. 2/5 of his times, and the lambs is this number here, 30. And again, we can do some cancelling here. So 5 goes into itself once, and 5 goes into 36 times. So 12 lambs get taken by Mr. Fox. And then the question says, how many are left? So that'll be 30, take away 12 equals 18 lambs that are left. And what I want to highlight here is that this bit here is the bit that you need to make sure you're including, because that's the thinking. Just writing 18 lambs as your answer without the thinking behind it is not what we would consider a complete answer. Okay, so now we need to look at some animal feed, and we've got 3 bags turn up. One of them's 2/5 full, one of them's 1/6 full, and one of them's 1/3 full. And the question is, we need 4/5 of a bag in order to feed our animals. Have we got enough? So we need to do an addition here to see how much we've got, and then we need to do a comparison to see whether that's enough. So 2/5 plus 1/6 plus 1/3, and we can see here that 3 and 6, we know that 3 goes into 6, so we can just do common denominators with the 6 and the 5 and know that the 3 will also work with that. So the common denominator for 6 and 5 is going to be 30. Okay, so we want to make these all over 30. And in order to do that, we times this one by 6, or we do to the bottom and do to the top. This one by 5, do to the bottom, do to the top, by 10. And so now we can go 2 6s are 12, 1 5 is 5, 1 10 is 10. And we can add across, so that's going to give us 10 and 12 is 22, and so it's 27 over 30. 3 goes into 27 9 times, and 3 goes into 30 10 times, so 9/10. And 9/10 is greater than, well, this is 4/5, which would become 8/10, then 8/10. Okay, so we have enough feed to feed the animals. We have a dot plot of children going and collecting eggs. And so the first question asks us how many children went to collect eggs, and so each one of these dots represents a child and how many eggs that they collected. So we see here that one child went and collected and they came back with 9 eggs. One child came back with 5 eggs. 2 children came back with 4 eggs. Okay, no child came back with 6 eggs, etc. Okay, so to work out how many children there are, it's simply a case of counting up all of the dots. And if you count all the dots, there are in fact 20 dots in total. So that's 20 children or 20 students that went to collect eggs. Now it says find the number of children that collected at least 2 eggs. At least 2. So that's all of the children that are this direction. They've all collected at least 2. Now, there's 2 ways of solving this. You could just count up all of the dots here and that will give you all that collected 2, or you could just go 4 and 6 is 10, so 10 didn't, and 10 from 20 leaves 10. So there were, in fact, 10 students who collected at least. So 10 children collected 2 or more eggs. Then it says calculate the median of eggs collected. Now we use the formula here of n plus 1 divided by 2. So the number of students is 20, we add 1 and we divide that by 2 equals 21 divided by 2. So that equals 10.5, okay? And so what we can do with that information is we can go in and go the 10th, so it's in between here, the 10th and the 11th, in between here. So the median is 1.5. Okay, so the 10.5 is in between. So this is the 11th person, and here's the 10th person, the 11th person. So 10.5 is in between here, so it's in between 1 and 2, so 1.5 eggs was the median that got collected. Then it asks us to find the mode. So the mode is the most common result, and clearly this is the mode. Okay, so the most common result is 1. So the mode is 1. And then the range is the largest number, which is 9. Take away the smallest number, which is 0. So the range is 9. Okay, so now we've got a comparing of fractions task. So we have animal land with 14 over 3 bales of hay. Please note the spelling mistake in the original question. And 9 compared to Lyndhurst, which has 19 over 5 bales of hay. And we need to see which farm has the greater amount. So it's simply a case of doing mixed fractions. So if we do 3 into 14, so 14 over 3 becomes 4 and 2/3 for animal land. And then Lyndhurst, 5 goes into 19 3 times. We can just compare the fact that these mixed numbers give us whole numbers, and that's an easier comparison, because that tells us then that animal land has 4 and 2/3, which is a larger number, so it has more hay. So 4 and 2/3 is greater than 3 and 4/5. Here we have the idea of bunnies, and we see 3 black bunnies, 4 white ones, 5 brown ones, 2 grey ones. It tells us then, we get asked then, what's the sample space for this? And this is just all the choices. So our sample space here is simply these words here, because they're the choices. If you were going to choose a bunny, what are the possibilities? So it would be black, white, brown, and grey would be the sample space, and we just need to use this fancy little bracket to do that. And the number for the span sample space you could add as 4, but these words are really what the question is asking you for. And then it says to find the probability of pulling out a black bunny, of selecting a black bunny. So that would be, the black would be 3, and it's out of the total number of choices. So that's 2 plus 5 plus 4 plus 3, so that's 7 and 7, so that's 14. So you've got 3 chances out of 14. That's already in lowest terms, so you can leave it as 3 over 14. And then it asks you what's the probability of a farmer pulling out a grey or a brown bunny. So grey or brown, so that's 5 plus 2, and that's over the top again of 14, okay? And so that'll give you 7 over 14, and that gives you a 1 in 2 or 1/2 chance of getting the grey or the brown bunny. B says, write an outcome for this event that has a possibility of 6 over 7. Okay, 6 over 7. So what we want to do here is we want to then convert that back to the original number. So we want something where we end up with 12 over 14. So what we're looking for here is combinations that add up to 12. Okay, so for example, 5 and 4 and 3 add up to 12. Okay, so black and white and brown all add up to 12. So that's one combination that would work. Okay, so that gives us 3 plus 4 plus 5. Okay, and that equals 12 over 14. Okay, now we have the idea of chickens eating their bag of wheat. So 3 chickens take eat one bag in 4 days. So that means that 1 chicken would eat 1/3 of a bag, okay, in 4 days. So what we've here is just divided by 3, and then we've divided by 3 here as well. Okay, so we're getting down to 1 chicken, 1/3 of a bag in 4 days, and so therefore, what would they eat? What would 1 chicken eat in 4 days? So then we want to divide that again. So it's 1 chicken, and it's 1/3 divided by 4. Okay, and so that equals 1/3 multiplied by 1 over 4 equals 1 over 12. So 1 chicken eats 1/12 of a bag in 1 day. Okay, so we're told we've got 16 days to wait. There's 3 bags of food for 3 chickens. Do we have enough to last? And so in other words, is there enough to get up to at least the 16 days? What we know from the original information we were told is that 3 chickens will eat a bag every 4 days. So if these 3 chickens will eat 1 bag in 4 days, then they'll eat 2 bags in 8 days, and they'll eat 3 bags in 12 days. So clearly they're going to be 4 days short. So no, they don't have enough feed for 16 days. They're going to be short.